Alright, so now let's look a little bit at programming. Like our Linux basics, this might be one that you could skip if you're already familiar with programming and scripting. You aren't going to need programming and scripting for this class in particular. The only time it really would come up is during the exploit development section, which I give you exploit skeletons specifically so you don't have to focus on the scripts and the syntax of the particular languages we use. But if you are going to continue with exploit development, you're certainly going to have to know at least some scripting and probably just with pen testing in general. Certainly if you ever want to write your own pen testing tools or plugins for some of the existing tools, or say a Metasploit module, and you may just find some script just doesn't work, and it should, and you're on a time crunch, and you need to be able to fix it. So it's certainly worth knowing programming. I mean, certainly there are plenty of pen testers who aren't programmers, but at least having a small amount of programming knowledge, I would say, would be pretty essential. So we're going to start with bash scripting, so B-A-S-H. Again, there are slides for this, as with all the modules, for you to look at accompanying the videos and as you work through this. So I've just come up with a few little exercises here. So for the bash script, we're going to basically do a ping sweep. So we saw ping in the previous section. We looked at, once we had set up our network, pinging another system to see if it was alive. We noted that the system doesn't necessarily have to respond to ping in order to be alive, but it's a good indication. So for instance, we could ping www.google.com and it replies, so we get 64 bytes from the IP address of Google. So we are getting a reply. If we do ping w.google.com, hopefully there's no, there is, maybe that's, so how about w.bulbsecurity.com, something that doesn't exist. So now we're not getting a response, so there is no w.bulbsecurity.com. So what might we want to do to make this a bit easier for us? If we, say, had an entire Class C network, so our /24 or 255.255.2550, so we had 254 possible hosts, and we wanted to see which ones were alive, which ones were at least answering to ping. We could do it manually, but that wouldn't be much fun, would it? Our time is much better spent on things that computers can't do easily. So we might want to write a script. So let's create a little bash script for that. I'll make this a little bit bigger. And so I'm going to use Nano. Again, I like Nano. You're welcome to use VI or another editor that's on here if you're more comfortable with something else. I'm just going to call this ping.sh for shell script. And what we want to do first, since this is going to be a script, we want to tell the interpreter, tell Linux what interpreter to use for this. So we want hash bang, so hash and then exclamation point, then slash for root, bin, bash. So we want to use the bash interpreter since this is going to be a bash script. After this we'll do Python, so we'll use a different interpreter. But for this one, bin bash. And basically in here we can just talk as though we're talking to the Linux system. We're just sending it a list of commands to do one after the other. So we want to say echo. We remember echo, right? That's going to write out to the screen. So I'm going to start with some usage about how to use this script. Alright, usage, :/. That's going to say run this program from the current directory. So we're going to do /ping scripts, or ping script rather, .sh. And we're going to have it take an argument of the network. So we're going to give it like 192.168.1, and it will ping .1 all the way to 254. So let's make another one an example. So echo example, well, let's make that a big E so they match. /ping scripts .sh 192.168.1. Let's go ahead and save this. I mean, right now all it's going to do is write two things out to the screen. Not particularly interesting, but we will make it more interesting as we go on. So we can go ahead and save this. Again, in Nano, that is Control X and then Y for yes to save changes. So if we just try and run this, we'll just do ping.sh, command not found. Well, for one thing, that's not how we call it. We need to call it from this directory, because that's where it is, right? We saved it here. So we can't just call it like that, whereas we can do like ls, so lots of stuff there. And I'll just clear that out. But if we see our path, so if I echo $path, we can see all of the places that Kali will automatically look for things. So user local sbin, user local bin, user sbin, user bin, sbin, bin. So if our script was in any of these places, it would automatically find it. So if I did ping script.sh, it would find it there automatically. But since we are actually in /root, it's not in our path, so we are going to have to call it by telling it where it is. So remember, dot is our current location, so /ping script.sh. It says no such file or directory. Again. Oh, it's called ping.sh. Whoops. And then it says permission denied. What have I done wrong? We do ls-l ping.sh. Remember our chmod and our file permissions. We don't have the correct permissions here. We need to execute. If I do a chmod 700, as long as you give root executable permission, you're good. Ping.sh. Now if we run it, we get our usage in our example, which are of course wrong because I called it ping script instead of ping.sh. We can fix that. Pretty easy. Alright, so we have made it executable. First step down. Awesome. Alright, so what next? We only want to output this if they use it incorrectly. For instance, if we do a netcat and then do, if I just do a grep and then nothing. We saw that when I did it wrong in a previous module. It gives us help information, so that's pretty typical. So we could do something like that here. What we're going to do is use a conditional. We're going to use an if statement. If statements are around in lots of different languages. The syntax may vary, but chances are you're going to have an if statement. So I'm going to say if, and how we do this in Bash, and again it is going to vary, so don't feel bad if you have to look this sort of stuff up if you know a lot of different languages. So I'm going to say if brackets $1. I'm going to put quotations around $1. So $1 is going to be the first command line argument that is provided. So if $1 equal, so one equal is going to set something equal to something else. So if I just did equal and then null here, that would actually set it to null. It would basically take what was there and overwrite it with nothing. So that's a very common programming mistake, one that people make a lot when they're starting out and even still afterwards. You know, as you continue with programming, it may come up. But you need double equals. That's going to be test for equality. So if our first command line argument is blank, then what we want to do, sure enough, the correct syntax is then, which again, that may be different. You may have brackets or something depending on your programming language. So then we want to do these echoes. And to finish an if statement, you say if backwards. Again, that may vary from language to language. So basically all we're doing here is if command line argument is equal to null or nothing, then echo this out. Otherwise, it won't do anything at this point. Of course, we'll want to add in some of that functionality later. Of course, we'll want to make it ping. But we'll do that next. Go ahead and save it. Run ping.sh with no command line argument. We get our output. Blah there. It currently does nothing.